The discrete uniform arises naturally when all the sample points are equally likely. So the PMF is just 1 over n for all the possible values, and you can define the mean and variance as you see on the screen. We have discussed this example in the last lecture. So if you have a fair die, then the 6 faces are equally likely, and we can define the mean and variance as 3.5 and 2.92. Now, this uniform distribution is also one that corresponds to the state of maximum Shannon entropy, which is defined as the sum of P log P. And we can just walk through a simple example involving a coin toss. So if the probability of head is P and the probability of tail will be 1 minus P, which value of P is going to make the entropy the maximum? And we could just find it using basic calculus, and the answer is half. So it is that state, the probability of head being half and tail being half, which maximizes the uncertainty. The next we will look at would be the Bernoulli trial. The Bernoulli trial in itself is not as important as what a sequence of independent and identical Bernoulli trials can give us, and that is 3 of the most important distributions that we'll encounter: the geometric, the binomial, and the negative binomial or Pascal. So let's look at the Bernoulli trial first. It has 2 outcomes, 2 possible outcomes, binary random variable. It doesn't have to be, but we most commonly assign the values 0 and 1 to these 2 possible outcomes. And we call 0 as the failure and 1 as the success, although success doesn't have to mean something good. It could just be that something that occurs that can cause problems, like the occurrence of floods or occurrence of earthquakes can be defined as the state of 1 in a Bernoulli trial. So 1 has a probability of P and 0 has the probability of 1 minus P or Q. And you can define the mean and variance. You can derive it simply by expanding the definition. So the mean of the Bernoulli trial is P and the variance is PQ. Now, I mentioned that what is most important is a sequence of such Bernoulli trials when they are independent and identically distributed. So what do we mean by that? Independent means that the different trials, if you look at them in sequence, they are mutually independent, and identically distributed means that the success probability P remains constant from trial to trial. So what you see on the screen is just one such sequence. The outcomes are either 0 or 1 on the y-axis, and on the x-axis is the trial number. So in this particular case, you see that the first trial is a failure, the second trial is a failure, and until the 5th trial, which is the first success, and it goes on until we have success again in trial number n. So the 3 random variables that come out of this consideration is, the first one is the answer to the question that when, at which trial number is my first success going to occur. I can also ask a related question that what is the time between occurrences or successes, or when is the next success going to occur after how many trials. So this gives rise to the geometric distribution. Likewise, I might be interested not in the first success, but I might be interested in success number k. and the question is that at which trial does it occur. So that gives me the Pascal or the negative binomial distribution. And if I have a fixed number of trials, out of them how many are successes, that gives rise to the binomial distribution.